Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera to everyone. My name is Iza Ismail from Fakulti Kejuruteraan dan Alam Bina, University Sains Islam Malaysia. For today's presentation, I would like to present regarding performance of radio over fiber free-space optics orthogonal frequency division multiplexing system under Malaysia climatic condition for wireless communication. First, as introduction, I would like to explain what is communication. Communication is the sharing of information, opinions, ideas, or feelings between two or more individuals who share a mutual interest. Nowadays, there are two mediums available for data transmission, which are fiber cables and wireless system. Fiber cable or optical fiber cable are built up of glass fiber strands inside an insulated casing that is used in telecommunication, which provides high-speed data transmission between 2 points. The wireless system offers communication with no physical connection between two or more devices, as wireless signal also can be transmitted and interpreted by suitable antennas through the air. Today, with growing demand for broadband services technology, high bandwidth, high data transmission speed, and high data transmission performance, wireless communication technology is the most appropriate solution that can meet all the demands. One of the most reliable wireless technology is radio over free space optic, ROFSO. The ROFSO is based on the concept between ROF system and FSO system. ROF is radio over fiber, which uses fiber cable as a medium between the transceivers in optical communication system that can be seen on the live figure. As of free space optics is an optical wireless network that transmits information from one place to another by using atmosphere, as can seen on the right side of the slide figure. The radio frequency signal and the optical signal need to experience a modulation process at a transmitter before the modulated signal can be transmitted to a receiver. There are two objectives in our research study. One is to design the radio over free space optics using opti-system simulation, and also another one is to simulate system performance that relies on Malaysia weather condition for future wireless communication. As of literature review, there are three previous studies that have been done that related to ROFS system. Between in these three studies, we can see that all the studies is different comparison and also different technique. First is only using the ROF system. The second one is using only MATLAB simulation. And the third one using a different modulation format, that is WDM modulation technique. As in the research, our research, the RFO system will be modulated with orthogonal frequency division multiplexing as the modulation technique to verify whether or not this system is good to be deployed in Malaysia based on its weather condition. Our system software is the chosen software that to simulate the RFO system, since the cost of instrumental is quite expensive. OFDM is a technique that has been applied wirelessly in communication, which divides the spectrum of a signal into an equal space subchannels, which carries a portion of users' information on each of the subchannel. Alright, in the research methodology, based on the objective that I explained before, we need to do two design. One to design RFO system, another one to verify its performance. To design RFO system, we need to select a different component from software tools, and to verify the system performance, we need to have to do analysis. One is using bit error rate, another one is constellation diagram. However, if the result is not good, we need to optimize the design RFO system to make it a better results later. In order to understand what is RFO system, this is the communication model of RFO system, where the schematic of the system created on the optic system later will be designed based on block diagram. The basic part of communication system consists of transmitter, channel that was built up from the optical fiber, and also free space. And the last one is receiver, where to see the output signal. To design RFO system, we use version 17. OptiSystem software. The software is very innovative, where we can use the simulation package to design, simulate, analyze system by using different visualizer provided at type of optical link. Okay, to design overall system design, we need to design first is the transmitter part. As shown in the slide, the design of the transmitter have two important components, such as QAM. Another one is OFDM modulator that were used in a transmitter site in order to carry out several functions before forwarding an optical signal through the transmission channel. One of the components used must be in high quality, have less error, and is always available to make the system operate smoothly. The reference wavelength was set at 1550 nanometer as it provides lesser attenuation compared to the other wavelength. The system was built up by setting the bit rate to 15 gigabit per second with continuous wave laser point of 15 dBm. Okay, the second part is channel side. As we can see in the figure, the components of the channel consist of optical fiber and also FSO channel. Both channels have its own advantages and disadvantages on how to transmit data from receiver to the destination. For an example, the fiber cable is more stable to radio frequency interference, low attenuation, large bandwidth, and easy to install, whereas for free space optic, offers a high security, large bandwidth, robust towards radio frequency interference, high data to speed, very cost effective, and easy to install. Transmission in FSO had a high security because the transmitter and receiver were installed on a very high building basically. As in our system, the optical signal will pass through both type of medium, which also means it will sum up the attenuation from both fiber optic and free space. However, for free space transmission, its performance can be infected by bad weather, atmospheric disturbance, scintillation, and alignment. Alright, for the last part is the receiver part. As we can see in the figure, to design the receiver part, we have three components. One is QAM detector, OFDM demodulator, and also the last one is photodetector. Photodetector is responsible to convert optical signal into an electrical signal later. Alright, in order to verify system performance, we use the formula as seen in the slide. Okay, this is FSO parameter formula where we set the different Q. Different Q is the how to determine the haze parameter. There are three. One is 1.6 when the visibility is more than 50 kilometer. 1.3 in between 6 kilometer and also 50 kilometer. And another one is the last one is 0.585 where the visibility is below 6 kilometer. Based on these different parameter, we can see that the fiber loss will be dependent based on the light wavelength, optical fiber length, fiber attenuation, connector loss, spice loss, and others. So in this from this formula, we set the light wavelength of 0.3 dB per kilometer for 1550 nanometer and also 0.5 dB kilometer for 1310 nanometer. Alright, for the as explained in the previous slide, the haze visibility data, we took the data from Malaysia Meteorological Department MMD that is based at Kelais, Sepang region from October 2017, from October 2015 and October 2017. So the visibility will be calculated based on attenuation value of 1550 nanometer as shown below in the table. Okay, for the minimum condition, maximum condition, and also average. From the two data, we do comparison between different haze parameter. Alright, for the result and discussion, first of all, we'd like to explain the RF spectrum analyzer. RF spectrum analyzer is radio frequency spectrum analyzer. Okay, in our system, we place the spectrum analyzer at both transmitter and also at receiver. This analyzer was used to calculate and display the electrical signal transmitted along the network system. Signal that launched in system will undergo signal degradation due to losses, noise, and also distribution. As can see in both results, it's shown that the maximum amplitude of the signal was approximately 40 dBm, and the RF pressure at the receiver side is about negative 41 dBm. This condition indicated that the power loss happened when the signal was transmitted from the transmitter to receiver due to the loss of an optical fiber, insertion loss, FSO range, and also attenuation. Alright, for the second result is based on the constellation diagram. The constellation diagram was used to explain the effect of interference on a signal. For QAM, that is quadrature amplitude modulation format, we eventually produces 4 points on a constellation diagram according to the modulation scheme. In the slide where the constellation visualizer was placed at the transmitter part, it can be seen that the 4 points are seen as 4 small blue dots. I'm not sure from the slide, you can see in here, here, here at the 4 points, it's a bit small. This dot appear when there was no signal impairments that can degrade the signal quality transmitter. Okay, the second result is based on the figure. Okay, we can see that constellation points are taken from two setting. One is during 5.65 dB kilometer and also during 21 dB kilometer on the right side. Okay, from the figure, the constellation points are separated far from each other compared to the constellation points from 21 dB kilometer on the right side. The cloud of all constellation points are increased until they are overlapped and merged onto each other when the attenuation was increased. Like an eye diagram, if compared with eye diagram, but now we don't have the eye diagram. The constellation diagram of the represents based on the real-time visual. It can easily shown that the changes of the system performance when the system changes or when the new distortion are added. It offers a strong indication to the nature of any problems of the demodulation and also decoding process of signal and the symbol of digital communication system when we use constellation diagram. Alright, we come to the end. That is conclusion and future work. As explained in the results, there are two results that we have shown. One is the RF analyzer, another one is constellation diagram. However, we need to study more based on bit error rate data. For in the future, we will study more on the new data, maybe 2019 data. Here's also a different type of weather condition. There is rain and also fog. For today's presentation, we can conclude that the research studied and analyzed the system performance of RFSO network by the process of simulation and verification the design model using real data of haze attenuation in Malaysia. So from this result, we can investigate the validation of the system design before deploying it into real RFSO communication system. As overall, to conclude the simulation results, as the range and attenuation increase, the received power at transmitter decrease, the distance between 4 points of constellation diagram also decrease. Based on the performance result obtained, the integration of RFO system is reliable to be implemented at future communication system development to provide good performance of data transmission. I think that's all for today. Thank you very much. Bye.
Assalamu alaikum. Today I would like to present my work which entitled Countermeasure of Intentional Insider Threat, a Systematic Review. In this presentation content we have introduction, aim, method, result and discussion, summary, conclusion and references. In introduction, many people still believe that handling the management of information security is a technology issue. It has been noted from the literature that with providing all of these technological techniques, human error are not avoidable, and intentional insider threats are the biggest insider risk of all. Intentional insider threat is defined as employee, former or current business partner or contractor who has or had access authority to the network, system, or data of an organization, and who, without malicious intent, damage the organization's information or information system through action or inaction. The aim to determine the countermeasures of intentional insider threat that have been reported in the literature. The work method, a critical review of existing literature of intentional insider threat countermeasure was conducted. A conceptual analysis and systematic review of previous literature on intentional insider threats was carried out. Moreover, the advantage and disadvantage of each approach were identified. Result and discussion. This study summarized a set of methods, tools, and technologies used as countermeasure against intentional cyber threats, which are listed here. Automation, the use of technologies to make decisions on behalf of the user. Standard operating procedure is a series of stages are followed for complete a task that used to reduce challenges caused by not following procedures. A trust model giving permission only to certain people for certain tasks such as certain rooms and certain files of cabinet. Brown solution of a human error. Brown solution to human error. For categories for coping with human error called error prevention, temporal replication, spatial replication, and temporal replication with re-execution. The first one is a precautionary approach, tries to stop error of a human for occurrence. The other three categories are targeting at error that have already occurred. Framework for human factors in information security. Instrumental conditioning is defined as learning by consequences where the positive system user behavior is reinforced while negative behavior is weakened. Generic model of human factor management by Theresic and Candos. A long period of absence of accidents expectation is based on the previous experience. That means user perceive the accident as a rare accident, and a long period of consequently attacks, user will expect a similar attack in the future. Collaborative reinforcement model by Suha and Maisara. The model proposed a collective monitoring to system users a breach to monitoring system users breaches to breaches of the policy. The model determine appropriate punishment, reward, and price of community based on the reporting false or real violation. Generic mitigation strategy of information leaks by one. The security tool presented generic mitigation strategy against intentional cyber threat in four domains that are organization, security technology, people and process. intentional side-directed mitigation strategy and countermeasure of Gritzel et al. This group came up with a countermeasure set of intentional side-directed. It divided into three domains: training and human factors, organization, best practice, and automated defense. Recommendation of the previous studies. Some studies, some studies recommended different countermeasures against intentional cyber threat in various aspects and domains in technology, organizational, and human factor domain. Summary: standard operating procedure and trust model doesn't include the technological, organizational, and human factor aspect. The literature criticized round solution to human error because it's required should be possible for the error to be anticipated prior to them occurring. One and Saurika framework and Teresic and Candos model are too theoretical and cannot be mathematically proven. Model of Suha and Maysara doesn't determine exactly the security issue which they study. Jeremy et al. Countermeasure and one's tool were most comprehensive and covered more aspects of a problem. Automation will not solve the problem of human error. The best solution, in the conclusion, the best solution to the problem of a human error is combination of discussed approach in this work. This work recommended one's tool expanding to additional countermeasure separately in each domain. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So the title of my presentation is about a study of object transparency via charge coupled device mathematical modeling assessment. My name is Sharfana Jiha and this is all the authors and the affiliation is from Electronic Engineering Program, Faculty of Engineering and Built Environment, University of Science Islam Malaysia, and also Balochistan University of Information Technology, Engineering and Management Science at Quetta, Pakistan. Next, this is the presentation outline, which will consist of the introduction, aim of research, methodology, result and discussion, the recommendation for future works, and conclusions. For the introduction, the charge coupled device or CCD is a sensor that has high sensitivity and accuracy, high frame rates, and low power consumption. The CCD linear sensor is sensitive to light received and beamed to it and then convert the output into voltage value. As the light intensity increase, the output voltage decrease. And next about the object transparency. Objects in this world have a tendency to selectively observe, reflect, or transmit light of certain frequencies. Materials that allow the transmission of light waves through them are called optically transparent. So figure 2 is the image of glass, water, and air, which all of them have different index of refraction as in figure 3. Okay, for the tomography process that have been used in this research, it was a process that involved the generation of narrow sections through an object. There are many examples of tomography such as the ultrasonic tomography, capacitance tomography, optical tomography, impedance tomography, and resistance tomography. So figure 4 is the basic block diagram of a tomography system. And next is the light characteristic, which have been investigated in this research. There are three effects occur with light as it passes through a transparent material light attenuation, which are the light absorption, light reflection, and light scattering. So in figure 5 is the light absorption phenomena, where the rays of light is observed when it passes a certain medium. Okay, so this is the application of tomography. Firstly, the medical imaging by using diffusion optical tomography or DOT, where it can detect the tumor in the brain. And next one is the in the oil and gas industry. For example, the electrical capacitance tomography can differentiate between the liquid and gas. And in the multi-phase flow industry, where it also can differentiate between the air bubble and the liquid. And the next one in the microcomputed tomography in powder industry, where it can detect the defect in the powder industry. So the aim of the project is to quantify object transparency through the medical modeling assessment by modeling the light characteristic equation based on the optical tomography system. Okay, so for the methodology, the general equation of final light intensity will create or establish from this figure. So this figure is showing you the cross-sectional flow pipe of the optical tomography, where it consists of several mediums such as the air, perspex, and water. Next, as you can see in the previous figure, there are several mediums that the light will passes through, which is the air, perspex, and also the water. So it will involve a certain light attenuation equation such as the light absorption and the light reflectance. So this is the equation for the light absorption, where alpha is the linear attenuation vector and x is the distance traversed by the beam of light. And for the light reflectance, it will consist in equation several parameters such as the R, N1, and N2, which corresponds to the refraction ratio, transmitted refractive index, and incidence refractive index respectively. Apart from that, this is the further methodology, which figure 7 showing you the flow of light transverse through the different medium in the optical tomography flow pipe. So this is the flow of light starting from the air to the perspex and then meet the water and then meet again the air, the perspex, and lastly the CCD, where there are two types of equation involved as I explained before, which is the light absorption and then the light reflection. And table 1 is the parameter involved in the mathematical expression, where if you can see there are no attenuation coefficient or attenuation equation of air since there are no light absorption occur in air. And it has a refractive index of 1.0. Meanwhile, perspex have a 0.003 millimeter of the attenuation coefficient and a refractive index of 1.5. And the water have the attenuation coefficient of 0.00287 millimeter and the refractive index of 1.33. So figure 8 and figure 9 is the full mathematical expression when there are air bubble of 1 millimeter size of diameter. And this equation will repeat with 3 millimeter and 5 millimeter and will be compared in the next slide. As for the result and analysis, the final light intensity equation from 1 millimeter size of air bubble is 0.6408. And then the output voltage of the CCD is theoretically determined using the formula of the 1 minus final light intensity received by the CCD, which is I4 times with 5. This is based on the CCD Sony ILX551A datasheet. The final light intensity equation is multiplied by 5 based on the maximum voltage output of this optoelectronic sensor. Then the equation is repeated by using 3 millimeter and 5 millimeter size diameter of air bubble. The relationship between the air bubble size, the value of its final light intensity, and the calculated output voltage of the CCD is shown in the table 2 below. So this is table 2, which is the relationship between the air bubble size, the value of its final light intensity, and the calculated output voltage of the CCD. As the diameter of air bubble increase, the distance of light transverse will decrease, which is the represented by the x in the light absorption equation. And then the value of the final light intensity, which is I4, will increase. Since the relationship between the voltage of CCD is inversely proportional, the voltage of CCD will decrease as the diameter of air bubble increase. Figure 8 will clearly showing you the relationship between the voltage and the size of air bubble. So as the size of air bubble increase, which means the light intensity received by the CCD will increase, then the voltage output of the CCD will decrease. So the relationship between the size of air bubble is inversely proportional to the output voltage of CCD. So for the future works recommendation, firstly, it is advised to establish the image reconstruction based on the linear back projection algorithm or the LBP algorithm from the lab view. So in this figure 9 is showing the image reconstruct from the LBP algorithm. And the next recommendation is to perform the real-time experiment by constructing the hardware of optical tomography. So in figure 10 is the hardware of optical tomography. In conclusion, this research indicates that the optical tomography system is able to measure the diameter transparent object. The final amount of light intensities received by CT will determine the existence of the object, for example, the air bubble in this research. And the transparent object, which is the air bubble, will penetrate light easily. And as the size of air bubble increase, the final light intensity received by the CCD will also be increased. This non-invasive and non-intrusive and radiation-free hardware has a bright future in the monitoring system of the multi-phase flow industry. That's all from me. Thank you.
Assalamu alaikum, everyone. Salamat pagi for all. My title is about the impact of Microsoft Teams app in enhancing teaching learning English during the coronavirus COVID-19 from the English teachers' perspectives in Jenin City in Palestine. I am Tahani Bsharat from USIM University, FPPU. First, I would like to talk about the impact of Microsoft Teams, especially during COVID-19, because we still in quarantine and all the universities and the schools were shut and closed. We need a solution to complete our education and our teaching, learning English language. First, a valuable environment of teaching learning process has been offered through the advancements of technology, which I mean e-learning. And e-learning defined as a learning system that is implemented by interactive means of media. And there's a lot of media like TV, like news, and many programs like Zoom, Microsoft Teams, etc. It was first used at 1999. Also, it knows as an interactive online learning. It gives a means of using the internet to share reading materials through emails, articles, webinars, or presentation. It has been essential characteristics and show enormous presence for the stage of teaching and learning. Then I will discuss the global influence of e-learning during COVID-19, constructions and cooperation, inclusion, meaningful feedback with rubrics, staff and learning communicators, OneNote class notebooks built into Teams, moving to the virtual classrooms. The methodology design. The researchers adopt a quantitative, descriptive, analytical approach. The population and sampling, the research was applied to teachers of English language in Jenin City, teaching in both governmental and non-governmental, which I know in private schools and education stage. The sample was chosen from the population of English language teachers and included 25 teachers, of course, male and female. During the instrumentation, a self-administered questionnaire consists of 15 items of one dimension developed by the researchers. Data analysis, the data was coded and analyzed using SPSS. Also, if you see this slide, the characteristics of the study sample, characteristics and the persons, gender male, 40%, female 56%. The age was for the teachers for 23 to 30 years, it was 20%, and the age for the teachers 31 to 40 years, it was 52%. Over 40 years, 28%. Years of experience, from 1 to 5 years, 28%, from 6 to 10 years, 24 years, over 10 years, 48 years. The results, teachers indicate that the most significant feature of Microsoft Teams is that enables students to share files and share content, and that includes screen sharing option that allows the teachers the freedom to display what they choose during class, indicating that it creates an interactive atmosphere between the students, teachers, and the community inside and outside the classroom, even for the parents, because it's very effective tool. The participants share the same attitude towards the impact of Microsoft Teams in enhancing teaching learning English during the coronavirus, COVID-19, of course, during the quarantine, regardless of their gender, as shown in the following table. The impact of Microsoft Teams app in enhancing teaching learning English during the coronavirus COVID-19, differences between participants during to differences in age-related share view with no differences among them in the impact of Microsoft Teams on enhancing education, as so in table number 5. The limitation and possible present scope. The study is limited to the impact of Microsoft Teams app in enhancing teaching learning English during coronavirus COVID-19 from the English teacher's perspectives in Jenin City during scholastic year 2020-2021 in Jenin region. The recommendation from the researchers. Number one, the researcher recommended using Microsoft Teams app and giving English language teachers, students, and parents online workshops on how to use the app. It's very easy. English language teachers have to pay more attention and get more emphasis on modern educational apps using Microsoft Teams app and the new apps such as Zoom, WebEx Meet during coronavirus COVID-19. Teachers should increase student self-esteem by allowing them to participate more through using Microsoft Teams app. Finally, the researchers recommended using Microsoft Teams app for the Ministry of Education to adopt using Microsoft Teams app. Finally, I would like to end my presentation because our current study characterized by rapid change resulting from scientific and technological process and information technology, and it has become necessary for the educational system to keep pace with these changes to face the problems that may result from the explosion of knowledge in the area of technology. And we should, inshallah, defeat coronavirus and the quarantine and move on for our teaching and learning English as a second language and move on in our life. Thank you for listening. Terima kasih for all. Tahani Bsharat.